Okay, I think that means it's recording. Okay. So I'm going to walk through today of how to access the hub and how to navigate your way through the hub once you get there. So this is more of information. We won't be going into too much of the programming side unless we have time. But this is something that I wanted to start with right off the bat. So we're doing this before the opening ceremony, which is later this afternoon. But I wanted to make sure that you all know how to log in and access the hub so that you can try out some of the labs and be ready for tutorials later in the week. Throughout the session, please feel free to ask questions. Unmute at any time, ask in the chat. This is rather informal. I want this to be more of a dialogue. So I'm going to start with what I think might be helpful, but please ask questions as I go. Okay, so this is the schedule. Hopefully all of you got this in an email. I also just posted it on the Slack workspace, which hopefully you are all members of, because we will have some communication through Slack during the week. And because we're all in different time zones, Slack is really useful for communicating asynchronously. So, so please do join. If you are not on the Slack workspace, if you go to the last page of the schedule, you have useful information in the Slack workspace. You can click this link to join. And here's a little bit about the different channels that we have with a little tutorial for how to use Slack from last year. Okay, so you open up the schedule, it looks like this. I encourage you to read through it. This has most of the information that you'll need for the week. On the second page, it has a visual schedule, so you can see what events are when. It also has a list of asynchronous content. So a lot of these are labs and pre-recorded lectures, and these are ones that you can do on your own time. And if you see a color that's the same, so for instance, the yellow that's up here, I can zoom in. So this yellow from 1 to 2 p.m. next Monday goes along with this asynchronous content. So there's a pre-recorded lecture and lab for marine biogeochemistry, and there's also a live a synchronous session from 1 to 2. So the color scheme is trying to help pair up those events. And right now you're at this tutorial here, Intro to Python Programming and Cloud Computing. And I can actually click on that and it will take me to the page that has more information about this event. So you probably all knew that to get here because you have all the Zoom link information here. And from here, you can read what this tutorial will do. And then it also has a link to the Jupyter Hub. So this is how you can access the Jupyter Hub. There is also at the last page of the document, I write a bit more about the Jupyter Hub and kind of what it means and what we'll be doing. There are also instructions for downloading and installing Python. If you'd still like to have Python on your own computer, that could be very nice. You don't need internet. You won't be able to access all of the data sets we'll be using, but there are instructions for how to do that. Okay, so if I go back to here, then you would click this link to go to the Jupyter Hub. So once you click that link, it should take you to this page here, which is the landing page for our Jupyter Hub. And as you can see, this is a Jupyter Hub that is set up just for us, for COESSING. It has our nice logo here, very exciting. And you can click, oh, yes, is there a question? Nope. Okay, I thought I heard something. Feel free to ask away. So you'll click here and the login to continue. And that's how you will log into the hub. You do have to fill out a Google form that's linked back over here, this Google form. And you have to fill that out with your name and email, and then I can add you as a user to the hub. And I just did that like 20, 30 minutes ago. So I think everyone on the list at the moment should have access. So you'll click login to continue. And when you do that, it will ask you to log in through your Google email account. And then once you do that, it should take you to a page that looks like this. And this is this interface here. It's through my web browser. And this is called Jupyter Lab. So if you were here in previous years, or maybe you've heard of it elsewhere, there are Jupyter notebooks, and that's what we'll be using for all of our Python coding today. Jupyter Lab is kind of an interface that's slightly different from the traditional Jupyter Notebook interface that we used in previous years. I can actually, if I go up here, and you notice how it says lab up in this URL. Oops. If I delete the word lab and type tree and then hit enter, this will reload all the same content that I just had, and it will be shown in a Jupyter Notebook kind of interface that we're more used to from previous years. So if you prefer that, you can do that. But the default is Jupyter Lab. And that's because, just gonna go back to the home folder, because it actually is quite nice. I think Lab is a bit nicer to work with. So we go back into the Lab view. So it should start up with something like a launcher. So it says launcher here. So you can click Python 3 if you want to start a new notebook. You might want to do that if you want to start your own, but basically all of the notebooks that you'll need for the week are here. So if I click on introductory Jupyter walkthrough, I double click on that and it opens in this new tab. And this is the Jupyter notebook that I can then run. So everything is kind of written for you, and then you can go through and run. You can read everything and run all of the cells according to the instructions. So if you'll notice, we're in this, this is the path up here. So you have this home folder, and then you have COESSING 2021 Hub, and that's where all of these are located, and that's default. It'll take you into that folder. If I click this home folder here, it goes back, and then I just have a few folders. You can ignore this notebooks one. That should not show up in your instance. This was just for my own testing purposes. But you'll see that there is a folder called shared. If we double click on that, we can see that there's some data here. So you have some .csv and some .nc files. And this is some data that will be used in some of the labs. The labs should work without needing to make any adjustments. But if something gets changed, then the path to your data is just the home folder. So you'd go /shared/ and then the name of the data that you want. So that's where that data sits. And that is read only. So you can't add data to it yourselves. Okay, so here's our list of notebooks. Let me check my list of what I wanted to cover. You can see here that I've opened one, this introductory Jupyter walkthrough. You can see there's a green dot here. That means that it's running. We have something that's called a kernel, and that kind of means that the notebook is ready to be run, that it's the kernel is going, so Python is ready to be used. If I go to this tab here, so we started in this tab here with this folder. If we go down one, it has this big stop button. We can see that it lists all of the notebooks that are currently running. And we just have one, so it lists that. And we have this button that says shut down. You probably won't need to use this, but it's good to know. You can shut down your kernel by going here. So if I click shut down, it goes away. When I go back over here, we see that there's no green dot anymore next to it, so it's not running. Now you can still see it here, but if you look in this top right corner, it says no kernel. So that means that if we try to run something, nothing happens because there's no kernel. So you can click on this no kernel, and you can say select the kernel, and the kernel that you want is Python 3. There are different versions of Python, but we want Python 3. You can select that and it'll start it up again. And now we can see that there's this green dot yet again. Okay, let's see, what else did, so a few more things about Jupyter Lab. If I open up another notebook here, let's say I wanted to compare these two notebooks side by side.
For a bit.
Oh, yes. Yeah, please.
When I logged into the Jupyter Hub, I could only see shared file folder, but I could not see the other folders that you mentioned.
You couldn't see the COESSING 2021 hub?
I couldn't see that. It's just shared folder that I could view now.
Okay. What link did you click to get to the hub?
It's from the PDF link that it was shared. The schedule.
Okay. I wonder if it's the wrong link. Did you click this one here that you can see on my screen under the Python programming?
Yeah, I clicked that.
Okay. That should be the right one.
Maybe it's because when I try to click again, there is some error in commands. I'm not sure if it's my some issues with my laptop or.
Okay. Did anyone else have this trouble? Has anyone else tried to log in?
Yeah, I have been able to log in.
Okay, and you didn't have any errors?
No.
Okay.
Maybe you can try. I think there's a tab below below the shared folder logo or icon. The one, it's a circle with a white square in it. Maybe if you click on that, you see that gives you just the sessions.
No, so the folders are listed in this folder tab here. So what I'm guessing happened, Nitya, is you can access this hub just from, so if I click up here into the URL, it's this really long thing. If I just deleted all this stuff after login. Did someone have a question? I'm hearing some noise. Okay, cool. You can log in with just this first part of the URL, but that won't sync to the folder that we want with all of the code in it. So I'm guessing that somehow you ended up on that page instead of the full link.
Yeah, I think what I will do is probably I will try with my another maybe a different computer and see whether it works. But I will just follow through your briefing for time being.
Yeah, you can still follow along, no problem. The other thing I would try is maybe right click and copy the link and then paste it yourself into your web browser.
Okay, I will try this and see.
Yeah, and you might need to log out of your hub first. So if I'm in my hub here, I can click File, Log Out. You probably want to try and do that first before trying again. If you do run into some errors, the other thing that might help, since I don't know if when you quit something and try again is like usually what IT support will tell you to do, and it works like a lot of the time. If you're in your hub and you're having some issues like Nitya, if you go to File, Hub Control Panel, it will open up this new tab and it will say Stop My Server and then My Server. This is a way for you to stop your Jupyter Hub. Oh, I heard someone maybe try and ask a question. But this Stop My Server will stop your server, and it's kind of like a strong way to do it. So if you're having trouble, click Stop My Server, click back on the link from the PDF and try again. Okay. I was getting some feedback. Okay. So yeah, good luck, Natia. I hope that helps.
So yeah.
Okay, I'm still hearing some noise. Does anyone have any questions? Maybe it's just me. Okay, go back here. Okay, so now I have.
Okay.
Sorry, I seem to be hearing someone. I don't know if it's my connection or not, but if you are not muted, please.
Let me mute mine. It could be me.
Oh, okay. Thanks,
Fake.
Jess. Still hearing a bit of feedback, but if you can all hear me, so I'm going to try muting Yewande. I'm going to try to mute yours. Okay. Yeah, that did it. Okay. Feel free to unmute yourself if I muted you. But for now, I couldn't hear myself. So, okay. So I have these two notebooks open now in these different tabs. This is just kind of fancy stuff if you want to use Jupyter Lab. You can take that tab, drag it, and you can see how it's kind of highlighting here in blue. So if I wanted to look at them side by side, I can do that. You can change, you can move that. You can move these over. This can be nice. Sometimes you want to compare to different notebooks. And you can move them into different places too. I can move the launcher into just the top half, and then you have three things open. So you can do some fancy things like that. This, I think, might be very helpful. So when you log in to your Jupyter Hub, you will go into this folder, but this is your work. So it's populated with these notebooks, but you can change the notebooks, you can evaluate them, you can make your own notes within the notebooks, and they will all be saved. So your work is saved in your own login. So if you do one of these labs and you're like, oh, this was a really cool notebook that I'd like to save for future use, you can right click on whichever lab you want to save, whichever notebook, and you can go down and click download. And that's how you can download to your own computer and save these notebooks for later use. This hub will be up for a while. It will not just be the 2 weeks. It'll probably be up for at least a week or two after the school, and potentially longer than that, but someone is paying for this. And they're actually being quite generous. And I will communicate that through Slack and probably through email, so you know when it will be taken down so you can save these things. But yeah, downloading is, and if you create a figure that you want to save, so you can save your figure, you can do the same thing. You can just right click and download. That's very useful. And since I mentioned it, I just wanted to kind of formally thank this. It's a nonprofit organization called 2I2C. And it's interactive computing infrastructure for your community. And so 2I2C is the one that made this hub just for us. They're pretty new as an organization, so we're one of their first hubs. So that's pretty exciting. And they were really eager to work with COESSING and to kind of try out their hubs with us and to see how they work for people based in, well, West Africa and kind of all over the world. So they've been very generous in that they're providing this service to us for free, which is really amazing. So I just wanted to kind of give them a shout out. And if you have any questions about them or want to read more about them, you can go to 2i2c.org. They're pretty great. And if you have more questions about that specifically, I'm happy to talk to you more about how it works. Okay, I think that's basically everything for Jupyter Lab. I wanted to show where these notebooks are coming from. So you all heard that when Natia had trouble I mentioned that there are some different links that you can use to access the hub. The link that is in the scheduled PDF is one that not only opens this hub, but it also syncs with this folder here. So this is we call it a repository on GitHub. And GitHub is this website that most developers use to develop especially open source codes. And it's a really great way to kind of share your codes and keep them organized. So this is my own account, and I made this folder, and I put all of the notebooks that we're using for this school in here, and it is synced. You'll see it's the same notebooks that you can see over here. So you don't really need to know anything about GitHub, but I wanted to mention it. If you do go here, there's this nice little button that you can press to get to the Jupyter Hub as well. But you don't need to know much more than that unless you're curious, then feel free to contact me and ask more questions. But that's how we are keeping all the notebooks synced. And if all goes well, I should be able to update. If I update any of these notebooks, the next time you click on the link, so if you're already logged in, it won't change anything. But if you log out and then the next time you log in, you'll see those changes here. So, so that's a nice way to keep everything up to date. Okay. Any questions about all of that? If not, I might go through kind of Jupyter notebooks and how to go through these notebooks. So kind of the basics of Python and basics of Jupyter, really. So speak up now if you have any questions. Nope. Nope. Did you have a question?
No.
Okay.
Sorry, no question.
Okay. Cool. So I'm going to go through this really briefly. You can go through this yourself as well, but this is a chance to ask some questions as we go, if you have any questions about this. So this is a Jupyter notebook. We're looking at one here, and you can see here that when I kind of click on these different pieces, you can see this blue bar here, which is kind of showing that I'm highlighting different coding cells. Oh, I just saw that Ebenezer said hello. Hi, Ebenezer. If you have a question, feel free to type it in and I will read it out. So that's how Jupyter notebooks work. It works in these cells. And the cells can be, so for instance here, this cell says this is a markdown cell. If we go up to the top here and click this arrow, we see that we can have a markdown cell. We can also have a code cell. And a coding cell looks something like this. And so that's where you can evaluate code. Whereas markdown is just a way to put kind of notes and text into your notebook. So if I double click on this, it opens up this cell and I can type. I can type in here. And then I can either click this play arrow up here, and it says run the cell. And then it looks, it's kind of typeset really nicely. Or I can type shift return or shift enter, and it evaluates the cell as well. All right, Ebenezer asks, can we have access to the GitHub link to the folder later after the summer school? Yes, so all of this, you'll have access to the GitHub link, to all of the content in GitHub forever. We won't take that away. It's just a question of we're going to kind of see how far the current funds take us on this Jupyter Hub to know how long we can keep it open. But as Joseph knows, we're actually potentially interested in working with some of you who are excited and want to work, especially with some of the large, like global climate model data or satellite data. that is on the cloud already. And so if you're someone who's doing research in those areas or are very eager to, let me know, because then we might want to keep the hub open for you all to work on that. So yeah, I think there's some exciting opportunities. And if you're really interested, let me know, because we'd love to keep this partnership up and see how far we can take cloud computing with all of you. I hope that answered your question, Ebenezer. Okay, so you can do some fancy things here. Like if you put a hashtag and then a space, then it makes it a very big header. If you just keep adding hashtags, it makes them smaller and smaller. So you can do that. So that's kind of a nice way to organize your notebooks. Some of the idea of these notebooks is to have code, but at the same time have text, so you can take notes or have explanations, like I do here. So I'm saying, let's do some coding. We can use basic Python. So I'm writing this out, and then you have code here, so you don't have to have your code stored in a different place. It's all one notebook, and you can have everything all together. Okay, so there are a few things here that you can read about, like how to create a new cell, which is this plus button. So you can just click that as many times as you want, and it keeps creating a new cell. If you created a bunch of new cells and like, whoops, I didn't want all those new cells, then you can click this scissors, which cuts the new cell. So you can select the cell when it's blue and then just cut, and it deletes it. Okay, so if you wanted to, okay, Muhammad has a question. If we delete or add a file, will it synchronize to everyone or only appear to me? That's a good question. It will only appear, if you add a file, it will only appear in your Jupyter Hub. The only way to populate into everyone's Jupyter Hub is through the GitHub folder, which I run, so I can do that. If you put something here yourself, or if you create some figures while you're running, anything that you add here is only visible in your own folder. So you don't have to worry about everyone seeing all of that. I hope that answered that. Cool. So, okay, so now we can just do some basic arithmetic. This is just, this is using Python because we have our Python 3 kernel. So we can see up in the upper right. And if I do shift return, then it gives me the answer. You can do multiplication, division, all this stuff. You can print things. You can make variables and all of this. You can also load libraries. So this will be really important when we do our analysis, because you're going to want specific libraries that can do fancy things. Like in this case, it's pretty simple because this is very basic. But we're going to import Numpy, which is the numerical Python library. So I can shift return, and you can see that it's numbered here. So we can see the number in which things have been evaluated, which can be helpful sometimes if you forget to evaluate something. You can see that it's out of order. And now with Numpy, we can get a sine function. And so we can calculate the sine of pi. You can create arrays, which is kind of like a list of numbers. And arrays are very useful, and that's how a lot of data is stored in Python. This is one where this is for plotting. You can say import matplotlib.pyplot. So that's the plotting package that we use most of the time. And we're importing it as PLT, which means when we want to reference it, we will say PLT dot. We actually, with Jupyter Lab nowadays, we don't actually need this line anymore. So I'll comment that out with a hashtag. We used to need this. Sometimes you still do, but usually you don't. This just means I would like to see the figure immediately. So I'll evaluate this, and then I'll evaluate this next bit where I called plt.plot, and you can see the figure. if you ever run something like this, where you run up,
Martin?
yes. Did someone have a question?
Yeah,
Yeah, go ahead.
yeah. Can you please, I think the writings are very small on the interface. I don't know whether we can increase it a bit.
Is that better?
Yes, please. Thank you very much.
Yeah, thanks. Thanks.
Alright.
Sorry about that.
Bye. Okay.
Sorry,
Um,
is that William? Just a
Yes.
Oh,
Yes,
okay.
yes, yes, doc.
Okay. William is my student. Let me just check it.
all right.
Yeah.
All right.
Thank
Glad to
you.
have you here. Yeah, thanks for that. I didn't think about that. And we have two people asking the same question. Well, we have access to the recording since you missed the beginning. Yep. So I'm recording this and I will post it as soon as I can. I'll try and upload it to YouTube. Yeah, in a few hours after we finish. And I'm also running the same session tomorrow. So tomorrow's session is meant to basically be the same. If a lot of you wanted to come again, then maybe we could do something else. But the plan is for it to basically be the same thing. So you could come again if you missed the beginning, or you don't have to come tomorrow, and you'll get most of the information from today. Okay. Yep, so here we can see that the figure showed up. If you ever run this and you get this line, but you don't see a figure, then uncomment this, and that should solve it. But nowadays, and with Jupyter Lab, we don't usually need that line anymore. So they're improving things. It's great. Let's see. So this is just how to make your plot look a bit nicer. So you can change the size, you can label X and Y, you can put a title on your plot, that kind of thing. So all of the labs will have some plotting and should have that kind of thing in it. But that's kind of an easy thing to play around with. And I do recommend it. You can get really far with really nice looking plots. People are very impressed when like, oh, it looks really nice. And if you're interested, especially in making maps, so if you kind of have geospatial data that you'd like to plot, go along to a tutorial that's happening next Monday by my colleague, who's also here in Australia, Josue Martinez Marino, and he will be talking about how to make your maps look really nice using a package called Cartopy. Did you have a question? No. Okay. All right, so some useful libraries that we're going to be using so these are Python libraries. One big one is Pandas. This is one of the most used libraries in scientific Python and in data science. It is very useful when you have tabular data. I think I'm hearing noise from someone, so I'm going to go ahead and mute them. So tabular data, meaning if you have, like a date and some measurement. So you have kind of date measurement and you have kind of like columns of data. Then Pandas is really useful. Oh, just a sec. We have another question. Which button on the keyboard do we press to evaluate input? I tried. Okay, so you have to hold down the Shift key and then press Enter. So if I have this cell highlighted, it's highlighted in blue. If I hold Shift and then press Enter, it evaluates. The other option is, I'm just going to zoom out briefly, is to click this play button here, and it runs the cell. You can also, if you go up into Run, this Run menu up on the top, you can run the selected cells. You can also run all cells if you wanted to run the whole notebook at once. So you have various options here. Okay, so Pandas is very useful for that kind of data. So here, for instance, this is just kind of dummy data. It doesn't mean anything, but you can see we have it in these like columns. So we have like some bogus date in column B, and we have some random other elements in these other columns. There are various things you can do with that. I'll let you kind of play around. Cartopy is one that I mentioned. That's how to make nice maps with your data. So if you have, anything ocean data or land data, atmospheric data, anything that you want to put on a map, it can be a global map or it can just be a regional map. You can zoom in or out as much as you want. Cartopy is really nice. NetCDF4 is a package to load NetCDF data. So a lot of the data that we use, at least in the climate sciences, is in NetCDF format because it has pretty good compression. So it's good for relatively large data sets. So you might need that package. We'll use that in, I think we have that in some of the tutorials. Xarray is very similar to Pandas, but it is for dealing with higher dimensional data. So whereas Pandas is really good for data that can fit into columns, Xarray is better for the multidimensional data, which a lot of, for instance, ocean or climate model data comes in. So I'm more in the ocean science space. So if you have an ocean model that has dimensions of, you have X and Y, so you have like latitude, longitude, but you also have depth of the ocean. So that's 3-dimensional, but then you also have time. So you have a 3-dimensional data set at each time step. So you kind of have like a 4-dimensional data set. Xarray is what you will want to use. And it's a really nice way to kind of package everything together. And it has some nice visuals as well. Not quite like this because it's not in columns, but it's some nice ways to visualize data. And we'll look at that in some of the tutorials. And it also is really great for handling very large data sets. So if you work with or want to work with any kind of global ocean or climate model or satellite data, they could be really big. And Xarray handles that really well. Okay, so that's basically it. That's just kind of an introduction of how to use Jupyter and then some of the packages that we will be using. If there are any questions on that, please let me know. I wanted to next. Oh, yeah. Yeah. Yes.
So is it a Cartopy? Is that a replacement for base map now?
Yes, it is.
Oh, okay.
Yeah.
Cool.
Yes. Yeah, good question. So basemap has been used in the past. It is no longer supported as of like, I don't know, a year or two ago. I believe you can still use it, but it's not being further developed. So Cartopy is taken over. Also nowadays, this is something I actually haven't done much of, so I can't give a tutorial on this at the moment, but interactive plotting is becoming quite popular, and there's something called HoloViz. And if you want to do interactive plotting, that's becoming quite popular as well. And that uses things like Cartopy as well to make nice maps. So but anyway, Cartopy is the nice map plotting of today. Okay. Hi, John. John has a question. Is there a tutorial for complete beginners? Yes. Okay, so it looks like a lot of you are quite new. So hopefully what I've said is starting to make sense of how you can use all of this. I'm happy to go through some of the more introductory things if you have any questions. But that's pretty much what this can do. And if you go through and read all of these comments, it might help explain some of these things a bit more. Or I'm happy to do more basic stuff at the end today or during the tutorial tomorrow.
Mhm.
Um,
And you do have some previous videos as well, right? Page on this
Yeah.
basic stuff.
Yes. Yeah. Thanks. Yeah. So I have, so actually, especially some of this stuff, we have all of the recordings from tutorials last year are available. And I also made some kind of walkthroughs where I did this exact thing, going through some of these. And they're all on the COESSING website. Actually, I can point. So if you go to the COESSING website, you see here it has 2021 school. If you go to past schools and click on 2020, and then you can scroll down to Python programming. This has a list of all of the labs from last year. It has some videos here on how to download and install Python because we didn't have Jupyter Hub last year. We also used Google Colab last year. Still a great resource that's available. You're welcome to look into it if you want. I won't go into it this year. And then these are some introductory tutorials. So the one that I just did, and also one for Colab. So, and here's a video of these. So you can access all of these. You can also go to the COESSING YouTube channel. I should probably make this link a bit easier. So if you go to YouTube, there we go, and search COESSING, you can see COESSING School has its own YouTube, and you can see all of the videos. So you can see here, there's a Thursday Python tutorial and a Wednesday Python tutorial. So we go through a lot of these basics there. Okay. There's another question. How do we install the packages and libraries like CartaPy in case I want to work from my own PC? Yeah, good question. So yeah, so it sounds like you know have a bit of background. So with pip install or Conda, most of them you can do via both. You could either use pip install or Conda install. I tend to use Conda install because Conda's kind of organizes the packages for you. So if you have Anaconda, I recommend Conda install, but some packages are not in Conda. And if I am curious how to do it, I would Google install CartaPy. Let's see if that comes up with anything. And usually it will tell you. So here it says you can use Conda install -c Conda forge CartaPy, or you can do pip install CartaPy. So when in doubt, Google, that's what I do. And yeah, so that's how I would do CartaPy. Now there is one comment about CartaPy. When I tried to install it locally, it conflicted with some of the other packages, which is what Conda is supposed to help with, but I still had some trouble with that. So if you have specific trouble with that, let me know. I think it should be better this now. I think I had some inconsistencies last year, but yeah, if you have trouble with that, let me know. But that should work. It might ask you to update some of your other libraries, and then you can click yes. Can I download a notebook from Hub and read with Jupyter Lab on Anaconda? Yep. So as I said, you can right click any notebook, just click download, then it'll go into your downloads folder or wherever downloads occur on your computer. And it will be a Python notebook, which is .ipynb. So it has this extension. Then you can just open that as normal through Anaconda. And yes, it works on Mac. So I have a Mac and it all works great. And it works on Windows as well. So yeah, then you would just want to put your Python notebook into, whatever folder you are opening your Anaconda or your Jupyter instance from. I hope that answers those questions. Let me know if not. Okay. So I wanted to talk a bit about cloud computing. So this is a notebook it's a notebook, but it is actually just text. So it doesn't have any evaluating, but I just wanted you all to kind of know what cloud computing is, why we're using it here, and why it's so exciting. So first of all, I feel like this is quite a buzzword, like cloud computing. So what is the cloud? So it's basically just a group of computers that are a group of servers that are remote. So whereas we have, like I'm talking to you right now from my laptop, that's my own personal laptop, and I have data stored on my laptop. The cloud is basically a collection of computers, but it can be anywhere in the world. And you're accessing them through the internet. And that's why it's kind of in the cloud. So it's somewhere else. I just need to get on the internet and I can access data and I can do computations on those servers from my laptop, but I'm not actually using the resources of my laptop. And so that's what cloud computing is. It's doing computations using these remote servers instead of something that's local to you. Sorry, I'll jump back really quickly. There's another question. Does this work with UTM data? I actually don't know what UTM data is. So Urias, if that, I hope I got your name right. If you could explain what that is, I will try to answer, but I don't actually know what that is. So yeah, if you could help me out with what that is, I will. Coordinates. So I'm not quite sure what the question is. Are you asking if the Jupyter Hub can work with UTM data? This might be a question I'll have to refer back to later. Sorry, so I don't quite know what it is. Feel free to message me about this on Slack and I can try and look up what it means to know how to answer that. Okay, so cloud computing. That's basically what cloud computing is. So there are many benefits to this, which I will go into in a bit. What does this Jupyter Hub have to do with cloud computing? Well, this Jupyter Hub is basically the interface that we're using to connect with the cloud. So this is running in a browser on my computer. And when you run Jupyter Notebook from your own personal computer, it runs through your browser. If you're familiar with that, then you may know that. But it doesn't actually use the internet. It just uses your browser as an interface. Jupyter Hub is very similar in that it uses a browser and it looks the same, but this one you need internet for because you are running this on servers that are remote. And so you need that internet connection to stay connected. It doesn't have to be a large internet connection. That's what's really great about it. It doesn't have to be high bandwidth. It just needs to be stable so that you don't get, logged out. And so that's really nice. So there are a few things that are really great about the cloud, and specifically for kind of what I know, which is like ocean and climate science. So when the normal way, like the traditional way to do computing in, say, oceanography, when you have an ocean model, so you have quite a lot of data, usually one university or an institution runs the model, and then they store it on their local servers, often called an HPC or a high performance computing server. And if anyone wants to access that data, they need to get a login to that institution's servers in order to access the data. And so Joseph may remember this because we worked together briefly back when I was a graduate student. A lot of time is spent kind of bringing data from one server onto another. And that's because if I'm at my own university, I have access to some computers to do my computations, but the data is somewhere else. So then I have to copy all the data to my local institution's server so that I can do computations on it. And that gets very cumbersome very fast if you have a lot of data. So that model works just fine if you don't have that much data. But these days, we're getting larger and larger and more high resolution models and other data sets that becomes a really big issue, that downloading data takes too long, it takes too much bandwidth, and it just is not feasible. So cloud computing, and one of the many things that it does is trying to get rid of that issue. So with cloud computing, if you have a data set stored on the cloud, so on these remote servers, you might hear, this is what's data proximate computing, where we're bringing the compute to the data. So instead of having to transfer data around to do the computation wherever you can locally, we're going to bring the computation to the data. So we will now be computing all of our data analysis on the cloud as well. And if the data set is on the cloud, then they're both together. We don't have to transfer data anywhere. So then the idea is we use internet, we connect to the servers, we can then access the data, we can do our data analysis on the cloud, and then we can save our figures for the paper or presentation or whatever. And we can just download those to our computers, which is much smaller than a big data set. So that's the data proximate computing. And that's one of the big things that cloud computing really helps with. And I mentioned this kind of cloud-based data set storage. It helps, was there a question? It helps with kind of more equitable access to data as well. So you still need to have access to like these cloud providers. So it's not perfect, but instead of requiring people to have to access data stored at specific computers at different institutions, so you kind of have to know someone to get access. The idea is that these are stored on the cloud and anyone can access them. You don't have to have specific credentials to do so. There is cost effectiveness, where which is kind of related to what I was saying before, where you're like downloading data into different places, which means you've got copies of these large data sets in many different places. And that can cost a lot of money because you have to store the data somehow and that kind of thing. In addition, so that can save on cost in that sense. But one that I think is potentially very useful for places like Ghana, Nigeria, and many other countries as well. A lot of institutions in the US or in Australia had funding, kind of startup funding, to be able to set up an HPC system. So this high performance computing server local to the institution. That takes a lot of upfront money. And then you can have all this compute and you can do large computations. What the cloud allows is people and institutions who don't have that much funding to put into the actual hardware, is you can access large compute nodes in the cloud and just pay kind of an on-demand service. So I could just say, I want to do this one calculation. I don't want to have to set up my own hardware to do that. That would be crazy expensive and time consuming. But I can just, the cloud is all set up. I can just go in, do my computation and pay exactly kind of a per usage fee. So I pay for the amount that I used. I think that's a really powerful aspect of cloud computing, and why it's really exciting to try and bring it to different countries around the world and help boost kind of the computational power that everyone has. So I think that's one of the most exciting things. Now I'm talking about some costs here. Note that the cost for using this for us is free. As I said, it's provided by 2I2C. So you don't need to worry, about this costing yourself. One thing I will say is well, we can get to that later, but when you're using the hub, use it, it's great. Please don't use it for other computations that don't have to do with the school at this point. And I can see people's usage, and if I see that your usage is very high, I'm going to have to cut you off. But when you are done using the hub, say you're done for the day, just log out and close your tab, like close the window. Because when we have them running like this, it does cost some money. It's not particularly expensive to have it running like this, but just be mindful of how we use it. All right, and the last benefit that I list here, there are several more that we could come up with, but is collaboration. So this is one where it's nice, where we could all, if we're all accessing the same data set and using the same environment, we can share our codes a lot easier and we can work together a lot better. Instead of saying, oh, well, I have all this data on my computer, but if I send you my code, you don't have the data, so you can't run it, that kind of thing. So it kind of helps us, ideally, hopefully, helps us to kind of all work together. All right, so there are a few things so when you use this Jupyter Hub, especially if you use the Jupyter Notebooks last year, if you didn't, that's fine. But if you have used Jupyter Notebooks before in previous COESSING years, you might notice that it's actually very similar. So in some sense, you're using the cloud right now. Whenever I'm running anything here, we're doing cloud computing. We might not be doing much computation, but we are actually using the cloud. But it doesn't really look or feel different. Like it doesn't, like it's very similar. And that's kind of the point of having this Jupyter Hub, is to mask all of that cloud computing thing that makes it much more challenging. But so as far as what you need to know for this school, there's actually very little difference from this Jupyter Hub to what we used previously on our local computers. One big difference is how the data are stored. So I won't go into this too much. You're welcome to read about it. You can kind of Google cloud optimized data. But cloud data is stored, uses object storage, which is actually a different way of storing files than our personal computers or HPC systems use, which are based on these file systems, which is kind of how we all think. We have a folder and then we have files in that folder, maybe another folder. And that actually is not how cloud storage works. And it uses object storage because it can be parallelized much better. And so it's much more efficient for very large data sets. So a lot of the benefits of cloud computing, as you can tell, are for these very large data sets, like climate models, ocean models, that kind of thing. So that's just kind of to keep in mind. And you will see, so I'll just open up, this is an Echo tutorial that I'll be going through later in the week. But to load in data from the cloud, so we're using Echo data. It's already stored in the cloud and all we have to do is load it in. All we need is these few lines here and we can load in the data set into Xarray. So if you're familiar with that, this is basically, these are the only lines you need to read in from the cloud. And that's because someone wrote this package called intake, which makes it very easy for us to load everything in. And we kind of we as the user can bypass all of the challenges of navigating cloud storage. So that's pretty cool. So I won't go into that more now, but we'll be doing that later in the week. So that's kind of the cloud computing in a nutshell. And that's why we're using it here this year in COESSING. As I said, it's a bit of a trial period for both us and for 2I2C to see how this all works. And we're kind of hoping that we might be able to forge a nice partnership with 2I2C moving into the future. So if you're very interested in being involved in that, please let me know. So I just was mentioning data sets. So a lot of what I have here, we have the Pangeo community to thank. So under more info, I have these links. So this is the Pangeo website, which is here. And Pangeo is a community platform for big data geoscience. So it's basically a community of people who do climate and geoscience like computing, and basically wanted to make something that kind of pushed the boundaries of what scientific computing was doing. And so it's really thanks to Pangeo that we have this Jupyter Hub, that we have, that we are using cloud storage and cloud computing at all in the climate sciences. And so that's pretty exciting. And Pangeo is a community, and it involves many people. So a lot of NASA people are really involved, and people from all sorts of other institutions are part of Pangeo. So Pangeo is kind of this umbrella group for people who are interested in this kind of thing. So if you want to learn more about this, the Pangeo website is great. There's the Pangeo data catalog, which if you're on the Pangeo website and you go to site, you have all these things to click on. So you can click Pangeo data catalog. Oops, and I just opened that into a new tab. Oh, sorry. Okay, there we go. And it takes you here, and it tells you that they're using like this package intake. They're using another one here. You can click the catalog, and this will take you to a list of all the data sets that are stored on the cloud through Pangeo. And we have access to all of these data sets through our Jupyter Hub. So if anyone here is very interested in working with a specific data set and you see it here in this catalog, so here's the catalog. You can click if you're interested in atmospheric data, climate, hydrological, or oceanographic data. So I'll click on ocean. That's the one that I usually do. And you can see there are all these data sets. So we have the Community Earth System Model POP ocean model. We have some GFDL models. You may not have heard of these, but if you have, these are some of the big global ocean models. This is the ECHO model that we are using. Or actually, this is, well, it's a state estimate. It's not a model, but we will be using this in tutorials later this week. So anyway, you can take a look at these and, play around. What's really nice is I'll click on, let's see, CESM. So if I click here on this high res control, sometimes it takes a little while to load that. Thanks, Joseph, for answering those questions. So here, this is all the information of this data set. So load in Python. So if I wanted to load this in our Jupyter Hub, I'd copy this, paste it into a notebook, and we can load the data. So I can do that. You can also just use this website to see what's here. It has all of the metadata. So if you're like, oh, I want an ocean model data set that has sea surface temperature, then you can go and look, list data variables here. You can see SST. And you're like, oh, I think that's sea surface temperature. You can go over here and click on this little kind of paper icon, and it will tell you what it is. So it says, indeed, it is surface potential temperature. It tells you the units, it's in degrees Celsius. And if you click this kind of cylinder here, then it shows you the size of the data. So I'm getting a bit into the details here, but it's pretty nice. You can look at the data here, see what you might want to play around with. You can go back here. You can start your a new notebook for yourself. And I'm going to paste the code that I had at the top. If I do Shift Enter, you can see when the star is here, it means that it's working, that it's running. And once the number shows up, so now it says 1. Oh, sorry, I should zoom in. Now it says 1. We know that it evaluated. And I can check that by typing DS, because in this case, it stores the data set in this DS variable. Shift Enter. Now you can see that star. It's thinking, it's working. And then it prints out the same thing that I just had on the other page. So you can see SST, it looks the same. I can click on these same, on the same icons, and it shows the same information. So that's kind of how we interact with data sets on the cloud. Okay.
Hi, Paige.
Yes, yeah.
Please, just to confirm, did you say the data set and then the code from the Pangeo website, we can only access it through the hub?
Yep.
Or we can do it locally? We
No.
can't do that locally. No,
Can't
okay.
do it locally, no. And you don't want to. This data set is very large. So if you see here, there are what, like 10 variables? Each variable is 500 gigabytes. So that would be a lot of data that you would not be able to store on your computer. So yeah, these are very large data sets that are meant to be analyzed and accessed on the cloud. So do not try to download them.
Okay,
It
thank
just,
you.
it will break everything. Yeah, and so that's kind of the point of the cloud, is that you can, interact with these data sets. So, so you're welcome to look around, and you could have a challenge of, oh, I want to plot SST. How do I do that? And I think my Wednesday tutorial will be going into a bit more of how to do some of the actual coding. This is the overview of how to use all of this stuff. So yeah, are there any questions about cloud computing or Jupyter Hub, or how any of it works? So we have about 15 more minutes before I have to go, but that's pretty much everything that I had planned to cover today. So I'm happy to take questions for the last 15 minutes, or we can end early if no one has any questions.
So I think that the best way is for participants to go through some of these, right, before maybe your next tutorial. Get familiar with the things. Otherwise, you come back without going through them, you'll still be confused.
Absolutely.
So
I think
best
yes.
practice.
Yeah, that is great advice. I think going through them by yourself, then you'll start to understand what you don't understand or what doesn't make sense. And I have tutorials every day this week. So hopefully you could make it to some of those. And tomorrow's tutorial is basically the same as today, but I have 2 hours for it instead of an hour and a half. So given how it went today, we may have extra time at the end for questions. Urias, you have your hand raised.
Yeah, good morning.
Hello.
Yeah, it's not a question, I guess a comment. Like we said before, that some of us just new to this. I haven't used a sort of data software operating system for a very long time. So I hope that during this period, I can be able to grab something that can make use of. So I'm hoping that this course will help me in something new, because I'm all new to this altogether.
Yes, great. I do hope this will help as well. And that is very good to know. Hopefully today's session helped you know how to interact with Jupyter notebooks. So once you open it and you get something like this, you'll know what it means, where you have these different cells. So that's where I encourage you to go through the Jupyter walkthrough and kind of maybe read each line. You can kind of understand that a bit better. I can do that over the next 10 minutes if no one else has any questions. And as we go through, so on Wednesday, I'll go through this lab here, which is kind of a long one using, we load some data, we take a look at the data and we plot the data. And so you get a better sense of kind of how the coding works.
Okay, just in a nutshell, I would like to know, what is this program all about. I was mentioning earlier about GPS, a UTM, which somebody went further to explain. It's the sort of data I think it's a map of UTM coordinates that we pick up on GPS or something to prepare maps, maps whenever we go out in the field. So I was asking if this data set can also be integrated, because most of what you've been talking about are all climate and ocean data. So that was, I was concerned about how can this be applicable on land. So basically, I would just like to know or have an idea what is this whole program all about? How can this, how is it important into our own geoscience background? Because some of us haven't used it before, and most of my work is centered around, or not more on ocean and climate. Do I got a background in geology and petroleum engineering, but I'm not having most of my work focused in those areas. So I would want to know how can this help me in my own background as a geologist, and where can I find more applications. So just to have an idea what's this program all about, because I'm just so new to it.
Yeah, okay, yeah, thanks for those comments. And yes, my background is very much in the ocean and climate modeling side, so it is a bit focused on that, and the examples tend to be from those disciplines. So what I think what will be helpful, so I'll have to look and see what UTM is so Ebenezer says it's a projection system. Is it a type of data set, or are you using like CSV files or .dat files or something for your data? That would be useful for me to know. So if that's the case, I think this notebook here that I'll go over on Wednesday might be the most helpful, because we load in a CSV file and then we kind of use that to do some plots. And this here can be run on your local computer. It's not related to the Jupyter Hub. Let's see, there's some new messages. Okay, so it is not a data set. So yeah, if you have certain types of data, so it'd actually be helpful for me to know what type of data set you have, if that makes sense, like how you save it. Like, does it come from kind of an Excel format or anything like that? That would be helpful. And if so,
when you download, usually when you have a series of forms, if I work with it can be downloaded in Excel form.
Okay.
X and Y coordinates, because they're actually in X and Y coordinates, so you can download in Excel form. I mean, you used to produce a map, so using a base map, geospatial map or something.
Okay.
Just a georeference, yeah. So I'm sure it has some interface with this, but I just wanted to know how can you find that, how can you integrate that into this kind of computing, or maybe because you mentioned of map production, so I just wanted to know how it's a UTM coordinate go into interface with producing map in different programs or something. Because it's actually more like used with georeference kind of GIS kind of tools used mostly with GIS as an input for GIS data.
Yeah, okay. Yeah, so you should be able to use a lot of these tools to load in your data sets. So for instance, if you have X and Y data, you could use either Pandas or you could use Xarray as well. And you would load in your data set using one of those two libraries, which we will go into more in these later tutorials this week. So you'll know more about what those actually mean. And you'd load into Python, you'd use those libraries to load that type of data in. So in this case, I have a CSV file, which is also one that was made through Excel. And then we can manipulate the data and we can make some plots, which we'll do on Wednesday. So I think the Wednesday tutorial might be the best. And I'll try and look it up more, or if you have like a small sample of a data set that you could send to me if it's small enough, then I can try and load it in and use that as an example, if that would be helpful.
Okay, I will see what if that's possible. Okay, no problem.
Yeah.
And okay, Paige, it also appears to me that Urias wanted to know in general what Python is about, if I understand, like the whole Python programming language thing.
Yeah. Okay.
Uh-huh.
Yeah.
Right.
Yes. Yeah. Thanks, Joseph. You have very wise words. Yeah. So Python is a programming language that you can use to do data analysis and make plots, that kind of thing. So if you've heard of MATLAB, Python is kind of an alternative to that. It's also kind of an alternative to Excel, where Excel is not a programming language, but it can do a lot of similar things. Python can do all of that and a lot more. So it's kind of a way to, if you have data, it's a way to look at it, do computations on it, make figures, that kind of thing. There is a strong GIS community, and they use some other specific GIS tools that I'm less familiar with. So it's possible that would be of interest to you. And I can try and pull up some links to that. But yeah, that's essentially what Python is in a nutshell. If anyone else has anything to add to that, please do.
No, I think that's fantastic, Paige. So if you have used MATLAB before, this is very similar. And then depending on what you want to do, you have all these different libraries that will help you to do that. So if you are dealing with data that is more like Excel data, then Pandas will help you. If you want to plot something like a map for your data, then CuttoPy, you have to import that in. That will help you to be able to plot your map data on a map, I should say. So depending on what you want to do, you can import different libraries that will enable you to be able to do what you really want to do. So it's really nice. I'm beginning to love it. I'm familiar with MATLAB, but I'm trying to move to Python now. And Paige is doing a very good job of these tutorials.
Okay, Joseph, that was well explained. I mean, thank you very much. I appreciate that.
Yeah, thanks, Joseph. That's very
welcome.
helpful.
Yeah.
Okay. Thank you.
Mm-hmm.
Yeah.
Okay, well, before we go, I would love, I'm gonna stop sharing because I have to go in a couple minutes. I would love to take a screenshot of everyone if anyone wants to turn on their camera so we can post some photos to the website. All right, it's great to see everyone. All right, I'll give you a few more seconds to turn on your cameras if you'd like. And I need to make this full screen and get the big picture. Okay. All right, any other cameras want to turn on before I take the photo? Okay. Yeah, no problem if you can't. There's no pressure to turn it on if you're unable to. Okay. Then I will, oh, we've got one more coming on. Okay. All right, I'm going to take a picture in, oh, I just need to wait for that to go away. All right, in 3, 2, 1. All right. Cool. Thank you, everyone. Got it. Cool.
All right. See you then, Paige.
Yep. Thank you
Bye-bye.
all so much. And thanks for all the questions. And thanks, Joseph, for helping out. That was really great. Let me look at the chat. Daniel posted, oh, I think CartaPy can handle them. Yeah, thanks for that. So Urias, you can check the website that Daniel posted. CartaPy is really good. It can handle kind of most map projections. So if it's a projection, then you should be fine. All right. Bye, everyone. Thanks again.
Bye-bye. Thank you.
Bye-bye, Paige. Mhm.
Bye, everyone.